Hi there. Welcome to Math with Mr. Bill. I'm Bill Anderson, and today we're going to be discussing a problem involving optimization. If you have any questions, please leave them in the comments below. Also, if you have any other problems that you'd like to see done, please put them down there as well. So let's take a look at this problem. We're asked, what is the shortest distance between the curve y equals the square root of x and the point 0, 3? So let's take a look at what we've got here, what we're dealing with. Here I've got a coordinate plane with the square root of x drawn in, and then we're looking at the shortest distance to this point right here. And so, we can draw in any sort of distance we want, right? We can go from 3 or 0, 3 to, we go there to, 4, 2. We can go from there to there. But there seems to be a sense that there should be some closest point right here. And we need to be able to find that point. With any optimization problem, we need to have a formula, some kind of formula that defines what we're working with, something that we can take the derivative of and determine the maximum or the minimum. Since we're dealing with the distance between a curve and a point, we're basically dealing with the distance between 2 points. And so we have our distance formula between any 2 points. I'll write that down. So the distance between any 2 points is equal to the square root of the difference between the x values and the difference between the y values of the 2 points. So I've got one point, right? I've got this point that we're given is 0, 3. But what about another point? Well, we've got the points that are going to be on this curve. So I got to be able to talk about what those points are. So any point on the curve here is going to have an x value. And then to figure out what the y value is, well, looking at my function up here, the y value would just be the square root of the x value. So I can call that my second point. So we'll say that point 1 is 0, 3, and then point 2 is x comma the square root of x. So now if we plug that into our distance formula, we get something very interesting. So we get the square root of x2 minus x1. So x2 is just x, and x1 is 0, and we'll square that, plus y2. Well, y2 is the square root of x, minus y1, which is 3, and we'll square that. So now I have this distance formula that just has x's in it. And I can take the derivative of that with respect to x. And we'll do that in just a minute. So let's clean this up a little bit here. So we have d is equal to the square root of x squared plus, and then we're going to square out the square root of x minus 3. Unfortunately, the radical won't get rid of it. It's got to stay under there. So I'll have the square root of x squared plus x. And we have minus 3 rad x minus 3 rad x. So it's minus 6 rad x and then plus 9. So there's the equation that we're going to need to take the derivative of and find the maximum for. Now, thankfully, the square root formula is always increasing. And that means that we could square both sides and we'll have a new function. But if we find the maximum of that, then it's going to be the same as the maximum of our distance formula. So we're going to take d and we're going to square it. And we're going to turn that into x squared plus x minus 6 rad x plus 9. And then we'll take the derivative of d squared with respect to x. So as I write this out now, I'm going to change the 6 rad x into 6 times x to the 1/2. Should make our life a little easier. Okay, so let's take the derivative. This is just like normal. So 2x plus 1 minus, and then 6 times 1/2, which is 3, times x to the negative 1/2. And plus 9, that's just going to give us 0. So we want to find the critical point to this. And so that means that we're going to set the derivative equal to 0. So trying to solve this now, we can put this into descending order. So we have 2x minus 3 times x to the negative 1/2 plus 1 is equal to 0. And we can do this by inspection. So the place where this is going to end up being 0 is at x equals 1. So x equals 1 solves this equation. There's really no other way to do that unless you plug this into something like Desmos or your calculator. So it's got to be x equals 1. So plugging that back into our function, so at the point 1 comma the square root of 1, or just 1, 1, that's the closest to the point 0.03. And that's it. That answers our question. That point 1, 1. Thanks for watching, and I'll see you in the next video.